Good evening to all. I am Dr. Sanjeev Kumar Singh. I am working at IIRS ISRO Dehradun. So this is the third day of this training program. I'm going to talk about the applications of satellite data for tropical cyclone study. So as you know that the tropical cyclone is considered as a disaster all over the world, and it can cause loss of life and damages over the coastal area. So the tropical cyclone is an extreme weather phenomena, and it is one of the biggest threat to life and property, even if in the formative stage of just their development. So even though the NIO, the North Indian Ocean, is the least active basin, it produces dead listed tropical cyclone over these regions. And NIO contributes around 7% of the world tropical cyclone. Since the Indian coastline is so long, around 7,500 kilometers, and it is very densely populated. If any tropical cyclone strike over these regions, damage can be happen more. Therefore, it is very essential to monitor and predict the tropical cyclone in timely manner. We know that there is a tropical cyclone does not form throughout the year over the Indian Ocean. There are main two seasons, that is called pre-monsoon season and post-monsoon season. In pre-monsoon season, tropical cyclone usually form during the March and June, and post-monsoon season it forms during October to December. So initially, few slides we will discuss something basic informations about the tropical cyclone. Then we'll go to the satellite application. So as we know that the tropical cyclone is a warm core system. It is a low pressure area, and it is a synoptic scale phenomena. Synoptic scale means it is about few hundred to 1,000 kilometers with organized deep convection which form over the warm ocean. So tropical cyclone can be defined like that. It is a well organized convection. It can extend at the horizontal scale of 100 to 1,000 kilometers. And not only horizontal scale, it can extend through the depth of the troposphere around 10 to 12 kilometers in the atmosphere. The tropical cyclone has a property at the surface, the wind rotate at anti-clockwise, and upper level it rotates clockwise, so in the northern hemisphere. So it has a property of the tropical cyclone, because tropical cyclone is a cylindrical kind of thing, structure is there. So surface there is a convergence, and upper level there is a divergence in northern hemisphere. And this criteria is just opposite in the southern hemisphere. We know that tropical cyclone is associated with the high wind, heavy rainfall, and storm surge. That is the major contributor to damage over the coastal area. So the question is, because the characteristic of the tropical cyclone is at the surface there is an anti-clockwise rotating wind. Whether we call all anti-clockwise rotating wind is a cyclone, the answer is no. So we cannot tell any anti-clockwise rotating wind is a cyclone. So there is a criteria set by the IMD over the Indian Regional Meteorological Agency for tropical cyclone categorization. If any disturbances happen, that is called a low pressure area, and based on the wind speed and pressure drop, it is categorized. If the wind speed is less than 31 kilometer per hour, and either you can say less than 17 knots. Knots I have used because it is universally used in all over the world. So if wind speed is less than 17 knots, then we call it a low pressure area. And correspondingly, this pressure drop is 1.0. Further, if this wind speed is increasing, that is called the depression. Around say 17 to 27 kilometer per hour, and further it categorized as a deep depression. And if the wind speed is 34 to 47 knots, then we call the cyclonic storm. Then it is the severe cyclonic storm. very severe cyclonic storm, extremely severe cyclonic storm, and super cyclonic storm. And at the category of super cyclonic storm, wind speed will be greater than equal to 120 km/h. And your pressure drop will be at the center, it is greater than equal to 80. So tropical cyclone is called over the India, it is named over the Indian Ocean. So the property and all those things is same. The thing is only name is different at different region. So over Indian Ocean we call as a cyclone. Over the Atlantic Ocean it called as a hurricane. And Western Pacific and South China Sea it called as a typhoon. And over the Australia it is a valley. So name is different, but property is more or less same. So there are mainly 6 major basins where tropical cyclone form. The Pacific Ocean has categorized into 3 parts. One is the Western North Pacific Ocean, and there is the Southwestern Pacific Ocean. And this part is called the Eastern North Pacific Ocean and North Atlantic. Called the South Indian Ocean. So this is some statistic about the tropical cyclone during the period 1997 to 2022. We can see this bar graph shows that on an average per year 4 to 5 cyclone form over the North Indian Ocean. If you divide this statistic into the Arabian Sea and Bay of Bengal, you can see the number of tropical cyclone formation over Bay of Bengal is more as compared to the Arabian Sea. Here, blue bar is the Bay of Bengal formations, and that green bar is the Arabian Sea formation. So some of the year where there is no tropical cyclone has formed over the Arabian Sea. The particular year in 2019, we can see the more number of tropical cyclone has formed as compared to the Bay of Bengal. Because of some studies says that during this year that sea surface temperature was higher. Due to this, the formation has more, and some study also suggests that ocean heat content during that period was high, and the reason the more number of tropical cyclone over Bay of Bengal formation is because of the sea surface temperature is high over the Bay of Bengal as compared to the Arabian Sea, and another reason is that because this Pacific Ocean, the tropical cyclone forms around throughout the year, and so many that low pressure and depression form because over the tropical region the wind flow is the easterly. So due to easterly, there is a very thin mass between Bay of Bengal and Pacific Ocean. So it crosses the land and reaches to the Bay of Bengal region. And if the favorable condition is met, that this low pressure develop into the tropical cyclone. So this is the region where Bay of Bengal, over the Bay of Bengal, tropical cyclone formation is moved. If you categorize in the percentage wise, we can see that during the period 1997 to 2022, 60% contribution of Bay of Bengal and 35% contribution of the Arabian Sea. If you see the last 10 years, this statistic not changed so much. It is only 1% difference is there. And this graph, we can see the depression and deep depression statistic. So more than tropical cyclone formation, the depression and deep depression form each year over the North Indian Ocean. But due to some unfavorable conditions, this depression has not converted into the tropical cyclone. When called as a tropical cyclone, it means the intensity should be greater than 34 knots. So they have not reached up to that intensity. So it dissipated in depression and deep depression state itself. So this is the trend analysis of during same year. We can see that there is not that much change in the number of tropical cyclone formations per year during the 1997 to 2022. If you see over the Bay of Bengal and Arabian Sea, also over the Bay of Bengal, that is almost, we can say, as a constant formation. But Arabian Sea, we can see slight increasing trend is there. Maybe this is due to the more number of tropical cyclone formation in 2019. Due to this, only this trend has so slightly increasing. Otherwise, there is a constant trend. So if you look at the last 10 years, also there is not that much change over the Bay of Bengal and Arabian Sea. So coming to the what necessary condition of the tropical cyclone, there is a dynamic and thermodynamic condition for tropical cyclone formation. This is the I listed here the necessary condition. This is not sufficient. Means if any cyclone form, definitely it follows this criteria. If this criteria is met, means it doesn't mean the tropical cyclone will form. So this is the necessary conditions. First condition is the sea surface temperature. If sea surface temperature is greater than 26.5 degrees Celsius, and this sea surface temperature not only at surface, it should be up to 50-meter depth. Then only the chances of the tropical cyclone formation will be more. Another condition is the atmospheric instability. Atmospheric instability means there will be the temperature difference between a lower level to a mid-tropospheric level. Then only this low pressure chances of the formation of low pressure. Another is the high humidity. So there should be high humidity should be exist. It should be around 50 to 60% in lower to mid-tropospheric level. And the most important criteria is the sufficient Coriolis force. As you know that that Coriolis force increases with the increasing latitude. At the equator, Coriolis force is 0. If you go toward the pole, it starts increasing. So due to this, tropical cyclone cannot form plus minus 5 degrees from the equator. Another most important criteria is the pre-existing low-level disturbance. So low-level disturbance is the seed of the tropical cyclone, because over the equator there is the intertropical convergence zone. There is different temperature form of the air masses meet, and due to this they form the thunderstorm kind of activity. Sometimes this thunderstorm form and dissipate. But if the some certain condition, it organize, and when organized, it form a low pressure. So that should that thunderstorm kind of activity should be pre-exist. And one of the also most important criteria is the low vertical wind shear. So wind shear is the change in speed with the height. If the wind shear is high, tropical cyclone cannot sustain for the longer time, because it cut off the moisture supply and moisture and temperature supply from lower level to upper level. That is the reason. That is why the tropical cyclone cannot form during the monsoon season, because during the monsoon season, this wind shear is very high. So how tropical cyclone form? I want to show here in this graph, in this picture. High humidity, the two major factors for tropical cyclone formation is the high humidity and sea surface temperature. So it contributes the major role to form the tropical cyclone. When any low pressure form, the evaporation start. So moisture start rising up, and when it reaches up to the height, certain height, because if you go to up, the temperature start decreasing. So due to low temperature, this evaporation start condensing, and it forms the cloud. So if this process goes on, it forms the low pressure column. So it forms the low pressure column, and around the low pressure column, wind start blowing. And if this low pressure is as it weakens, the wind speed start increasing. So it is the inversely proportional. If the pressure decrease, your wind increase around the low pressure area. So this is all about the tropical cyclone formation. So this slide shows the energy potential of the tropical cyclone, from where the tropical cyclone gets their energy. So mainly the energy input is warm water and humid air. They take the energy from there. So as you know that the moisture, when the low pressure form, moisture goes up into the troposphere at higher level, it contains and form cloud. So during the condensation, it converted into water droplet, and in this process, it released the latent heat, and this latent heat converted into the kinetic energy. Some amount of the latent heat is converted into the kinetic energy that maintain the tropical cyclone circulation and wind field. This is the this slide shows the structure of the tropical cyclone. So right side picture shows the vertical cross sections, and left side this picture. You can see at the center there is the I bar. I is mainly the cloud-free region of the calm wind. There is no wind, no cloud. It can extend up to 30 to 60 kilometer in diameter. And I is the region where the lowest surface pressure exists, and temperature increases with the height. If you take the differences from the center to outside, the temperature will start increasing from a lower to upper level. And surrounding the eye is a dense convective cloud that is called the eye wall. So this eye wall can extend up to 10 to 12 kilometers in the troposphere, and the eye wall, the region where highest surface wind exists and maximum intensity of rainfall exists. So eye wall is the region where if cyclone hits, it can damage more over this area. Another property of the tropical cyclone, structure of the tropical cyclone, is the spiral band. If you go further from the center, so you can see a long, narrow rain band, which is oriented in the same direction as the horizontal wind. So because of this narrow band, it's called the spiral band. Spiral band, and it can call it the rain band also. So it often extends up to 1,000 kilometers from the center. That is the responsible for the rain. So the thing is, whenever the tropical cyclone form over the Indian Ocean, it gets the name. So what is the criteria for getting the name or giving the name? So first time it is started after World War II, and subsequently it is adopted from the by all the region. So when they started, it predetermined alphabetically list they have taken based on the male and female name. But our North Indian Ocean, the majority of the name used from not from the personal name. It is mainly the flower, animal, birds, tree, or foods name. So it is started over the North Indian started naming was started since October 2004. So there is a neighborhood country of the India, the Asian countries, around 13 countries. There is a group, and they decide what will be the name of the next cyclone. Every year they provide the list of the name, around 10 names, and once the tropical cyclone form over the India region, it will take from over one country. Once the next cyclone form, so it can be taken from the next country. So alternately means one by one they take the name from different country, and once its cycle is over, then first country will name again. They will take. So you can find, if you Google, you can find what will be the upcoming cyclone name is there. So you can easily find that. So, and then why the tropical cyclone wind rotate anti-clockwise over the over the northern hemisphere? The major factor is the Coriolis force. Basically, Coriolis force is the apparent force that is formed due to the Earth rotation. So you can see whenever any low pressure form, wind start blowing from high pressure to low pressure due to the pressure gradient force. And the same time, because the Coriolis force has property, it pulls the any moving object on the Earth's surface to the right direction in the northern hemisphere and left direction in the southern hemisphere. So when wind start moving from high pressure to low pressure, you can see this this part of this wind. This, due to the pressure gradient force, wind start moving from high to low, and at the same time Coriolis force act, and it try to pull the wind at right direction, and the resultant path of the wind will be like that, anti-clockwise. So likewise, the wind start moving anti-clockwise direction. So what will be the path when the tropical cyclone has formed? What will be the general path if not major factor contribute? What will be the general path of tropical cyclone? This is the global distribution of the wind. We can say that this is the ITCZ, intertropical convergence zone. This is the subtropical high in plus minus 30 degree, and if at plus minus 60 degree, you can say subpolar low and subpolar subtropical high. So over the tropics, the wind is normally easterly. Whenever the tropical cyclone form over the North Indian Ocean under the influence of this easterly wind in the tropic, it start moving toward the west. So tropical cyclone vortex start moving toward the west. When it reaches up to a certain latitude, then Coriolis force start acting, and it try to pull the wind in right direction. So tropical cyclone start moving toward the poleward. You can say northward. Once the tropical cyclone move poleward of the subtropical high, this is the area of subtropical high, it begins to move eastward under the influence of the westerly. So this is the general movement of the tropical cyclone based on the wind pattern. Coming to the landfall, because everybody is curious about know where tropical cyclone is going to hit, tropical cyclone going to make a landfall. So landfall is the event of the tropical cyclone coming onto the land after being the water. So these picture, I like to show this picture always because these are the tropical cyclone location, top and bottom picture. You can say because most of the part of the tropical cyclone in bottom picture inside the land, but we cannot say this cyclone has made the landfall. We can only say when this I portion hits the land. So in the top panel, we can say the tropical cyclone had made a landfall, but in the lower panel image doesn't show the tropical cyclone had made a landfall. So what will be the impact when the cyclone is associated with measure this three type of parameter, that is strong wind, storm surge, and heavy rainfall. So these are the factors that affect over the coastal area, that is the responsible for the damage over the coastal area. So due to the strong wind, we can say we can see the number of damage can happen. So due to the strong wind, damage can be happen to the structure. It can be loss of power and communications, loss of life and injury, generation of devastating storm surge, destruction of vegetation and crop. And storm surge mainly happen due to the wind and pressure drop. If the storm surge is more, the flooding can be happen over the coastal area. It can erode the basis, loss of the soil, of the fertility from the saline water, because when the storm surge happens, that a lot of saline water come into the land portion, and it can reduce the fertility of the soil, loss of the life, and it can damage the structure also. Due to the heavy rainfall, there will be the flooding kind of condition. It can be destruction of the vegetation and crops. So contamination of water supply and land subsidence can be happen. So so many things can be damaged by the tropical cyclone. So I am coming to the satellite applications. Before that, I want to show what is the observations over the tropical cyclone. So first observation, because the tropical cyclone spend most of the time, most of the life over the ocean. So what is the measurement for the tropical cyclone wind and all? First thing is the ship measurement. In this measurement, the meteorologists take the ship inside the ocean and take the measurement of sea surface temperature, wind, salinity, and all those information. Another instrument is the buoy measurement. Buoy is the instrument which is installed in the ocean. It measures the wind, temperature, sea surface temperature, and other parameter of the ocean. And another is the land-based observation. Land-based observation in the coastal area, there is a radar and other AWS station also. It can measure the wind and other parameter. Aircraft also plays a major role for the during the tropical cyclone period. But above all observations are specific location based. That is not everywhere. So, and it is also sparse. That is not a good number of observations that you can monitor continuously the tropical cyclone. So in this case, the satellite plays a major role to monitor the tropical cyclone in timely manner. So you can see this is the picture of the polar geostationary satellite and low Earth orbiting satellite. We have a good number of satellite, meteorological satellite. We can say atmospheric applications for atmospheric applications and ocean applications. You can see a large number of network is available. So you can use these satellite observations to avoid the disaster. So over India, you can see that INSET series is there. INSET 3DR observations. OceanSat 1 and 2 is giving the wind information and other parameter. SCATSat 1 is there. OceanSat recently launched. And Megatropics also, it provides the temperature and moisture profile over the tropical region. So we have a good number of satellite and observation through which we can continuously monitor the tropical cyclone activity. So once the tropical, this satellite provides the information about the tropical cyclone, how you can interpret that information. So in the satellite imagery, like infrared, visual, and water vapor. In infrared, mainly it shows the temperature of the cloud tops. This shows the deep convective organized convection characteristic of the tropical cyclone. And because this IR sends the energy as a heat. When the sunlight falls at the Earth's surface, some of the energy absorbed and some are re-emitted. Similarly, that atmosphere and cloud also, it absorbs and re-emit. But this absorption is very small as compared to the Earth. Also, once the IR image is available, you can find out the deep convective cloud over the tropical cyclone region. And not only the storm location, you can also find out the wind speed, because the certain cloud can give the information about the wind. Further, if you look at the visual imagery, it shows the high value of reflectivity because of the cloud high albedo. You know that in the tropical cyclone, it is a deep convective cloud. It contains a lot of water droplet. Okay, so when the sunlight falls over the tropical cyclone region, it's reflected back. So because cloud has a high albedo, due to this reflectivity is very high, and so you can easily identify the tropical cyclone location. But the disadvantage of this visual satellite is because it measures the reflected energy, sunlight energy. So during the night time, it is not available. Coming to the water vapor channel, in water vapor channel, it measures Mainly it measures the moisture. So where moisture is moved, because the tropical cyclone contains a lot of water droplet. So you can easily identify the where is moisture is moved and where the heavy rain can be happen. So easily you can identify. And that is there is the microwave channel is also there. Microwave channel has advantage because due to the longer wavelength, it can penetrate the cloud and it reaches up to the Earth surface. So you can get the informations about the atmosphere and Earth, even the cloudy situation. Not only cloudy, you can get the information during the rainy season also. So you can see this animation. This is the IR. Mid panel shows the visible, and right panel shows the water vapor imagery for the Amphan cyclone. Because Amphan cyclone is one of the super cyclone which formed in 2020 and for the West Bengal. You can see this visible channel during the night time. This information is not available. However, this IR and water vapor channel is continuously providing the information of the tropical cyclone. So India has so many meteorological satellites, instead 3D, 3DR, SCATSat, megatropics is there. So these satellite has been utilized for tropical cyclone activity. You can see the SCATSat 1 because this is the polar satellite, so it provides the observations twice in a day over the Indian region. And megatropics, because this is the low Earth orbiting satellite, it is mainly provide the temperature and moisture profile over the tropical region. So easily you can find out the tropical cyclone location, and we can find what is the center position of the tropical cyclone and what is the structure of the tropical cyclone. Center of the to detect the cyclogenesis of the tropical cyclone. Actually, cyclogenesis is the formation of the tropical cyclone. In this Cristobal in 2011, what they did, they have taken the spectrometer wind data and prepared the database, because they have taken the database from 2000 to 2008. So they have used the QuickScat wind data. QuickScat is the foreign satellite that is similar to our SCATSat and OceanSat 3. So it provides the wind information. They have prepared the database during 2000 to 2008 over the North Indian Ocean. What they did, they have taken the center position from the JTWC site, and from the center, they have taken the wind domain 31 by 31 size, because polar satellite sometime coverage is not available over the cyclone region and sometimes available. So they have decided that if the 60% more than 60% coverage is there, then only they took the scene. Otherwise, they have discarded. So using this criteria, they have found that around 133 scenes they have found. And how they found? They have taken the data from the formation of the tropical cyclone before 4 days, 96 hours prior. And the formation of the tropical cyclone is taken from the IMD and JTWC. When the tropical cyclone, like today, tropical cyclone formed, they have taken the 4 days prior wind information. So doing so, they have collected around 133 scenes, and then they have applied this in real time. How they applied? Whenever the tropical cyclone forms, they take the spectrometer wind and try to match that wind with the real situation. So reference scene they have, it's coming from the database, and analyzing scene is coming from real time spectrometer observation. So they have used this formula to compute the matching index. So this matching index they have computed at each grid point of the domain, study domain, and the maximum matching index is considered as the Cmax, and the location where maximum matching index has found, that is considered as the center of the tropical cyclone. And also, if this maximum matching index is greater than 0.6, they have set the threshold. If this Cmax is greater than 0.6, it means this low pressure has a potential to develop a tropical cyclone in future time. So based on that, they are able to predict so many low pressure that this low pressure will develop in future time. So how they are doing, so you can see this is the database wind pattern, and this is the real time. If any cyclone form, that this is the, if you consider this is the real time wind field, and this is the database. So it is computed at each grid point, this matching index, and where the matching index is maximum, considered as a center of the tropical cyclone. And if this matching index, maximum matching index, is greater than 0.6, is considered that this low pressure has potential to develop into the tropical cyclone in future time. So using this criteria, they have predicted so many cyclogenesis in the real time. Some of the result I have kept here. You can see this image. This is the matching index for the Amphan cyclone. Amphan cyclone has formed on 16 May at 2020 at 12 UTC. So on 15th May, they are able to predict that this system is going to develop into the tropical cyclone. Means it is able to predict at 33 hours per hour, this low pressure will definitely develop in the tropical cyclone. Similarly, for Nisarga cyclone, it also formed in the same year at on 2nd June at 06 UTC. This is the wind wind picture of 1st June, around 3:20 UTC. So they are able to tell that this low pressure is going to develop into the tropical cyclone. So using the geostationary satellite information, how center can be detected. One of the study I have kept here. This is again done by the Neeru Jaswal and Dr. Singh. They have used the IR image, brightness temperature of infrared channel. What they did during the tropical cyclone period, they have taken the brightness temperature and then computed variance of this image. First, the gas center they have taken from the either AMD or JTWC. During the around the gas center, they have cut the image around 401 pixel to 401 pixels, and then each pixel they have computed the variance. After computation of the variance, they have computed the gradient of this variance. So you can see in the variance image where the low value of the variance, it shows the axis symmetry around the center. So axis symmetry is the prominent feature of the vertex in the tropical cyclone. So after variance computation, they have computed the gradient of this variance image in the variance image. So after that, they have drawn the, you can see in this picture, they have drawn the line parallel to the gradient, and where this two line crosses, that point is considered as a density matrix. And this way, they have prepared the density matrix, where the maximum line cross, that point is the maximum density is considered as the location of the center of the tropical cyclone. So using that, they are estimating the center of the tropical cyclone during the real time. They have estimated so many center, and they are providing the real time on the operational manner. Now coming to the intensity estimation, because intensity is one of the major parameter of the tropical cyclone. It decide how much dead list tropical cyclone can be. So for the intensity estimation, there is a well-known method that is called the Dirac technique. This is the only method where we can use the to identify the intensity or to generate the intensity of the tropical cyclone. So in this technique, mainly they are using this IR and visible channel. So based on that, because they have categorized the cloud pattern in the four category. That is basically the curve band pattern, shear band pattern, and central dense overcast pattern, and I pattern. In the curve band pattern, in the formation stage, the tropical cyclones start organizing. That is called the curve band. Shear band pattern you can see during the formation stage are when the tropical cyclone hit to the land during the dissipation stage. So in the both stage, tropical cyclone is not that much strong. Central dense overcast pattern, it shows the formation of the eye wall. When the this eye wall start forming, that situation is called the central dense overcast eye pattern. When the tropical cyclone is developed and eye is visible, that is called the eye wall pattern. So the basis behind this method is that this technique relies on the four distinct geophysical parameters that related to organize the cloud pattern to the TC intensity. So two are kinetic vorticity and vertical wind shear, and two are the thermodynamics, convection, and core temperature. The strength and distribution of the circular wind in the TC organize the cloud into pattern the Dirac related to the maximum sustained surface wind. So this is the method. Actually, in the Dirac technique, they have measured the intensity in 1 to 8 scale. They have they assign the T number. T number is basically the unit represent the typical one-day intensity change based on the climatological data. So first, if they take the images and try to find out the pattern, and if based on the pattern, they assign to the T number, and this T number they have for conversion of T number to current intensity, they use this table. So if T number is 1.0, so intensity will be 25. If T number is 1.5, intensity will be 25 knots. So based on that, they are providing the intensity information of the tropical cyclone. So another application of satellite data is the you can always use the satellite observation into the numerical weather prediction model to forecast the track. So because SCATSAT, our Indian satellite, so we have assimilated this scatterometer wind in the numerical weather prediction model. So we try to see what is the impact of this scatterometer wind on the track forecast and intensity forecast. So SCATSAT wind we have assimilated during the Kyan, Nada, and Varda cyclone. It forms in 2016. So this is the 850 SPA wind model analysis of the Kyan cyclone. You can see after this picture, left wind picture shows the without SCAT data assimilation, and right picture shows the after assimilating the scatterometer wind. So you can see the orientation of the tropical cyclone has changed after assimilating the scatterometer wind, and you can see the very well organized structure of the tropical cyclone after assimilating the scatterometer data. So we have found that the tropical cyclone forecast has improved when we have assimilated the observations which is available over the tropical cyclone region. So you can see here in this track we we have done two type experiment. One is the control and another is the scat set. In the control run, we have not assimilated the spectrometer observation, while in the scat set, we have assimilated this spectrometer observation, and we have compared the track based on the IMD base track, and you can see this blue is the control and red one is the after assimilating the spectrometer. So this track has improved after assimilating the spectrometer wing, and also we have found that that mean absolute error of intensity is also reduced. So this spectrometer wind field has done a positive impact in the tropical cyclone track and intensity prediction. So in the real time situation, because the IMD is the operational forecast agency, they run so many models. The operational model is the GFS, and other model is also they are running. So they are daily assimilating number of satellite observations. So whatever satellite observation going into the numerical weather prediction model, based on that the forecast has improved a lot. So they are assimilating that atmospheric motion vector from geostationary low Earth orbiting satellite from imager from GOES 15, Himawari 8, because they are assimilating not only Indian satellites, they are assimilating a lot of foreign satellite also. Very high resolution radiometric observation from NOAA 15, NOAA 18, NOAA 19, META A and META B. These are the foreign satellite. Imager channel from 3D, 3DR. Spectrometer wind, they are assimilating the scat set from META A, META B, and scat set 1 and ocean set 3 recently launched. If the data is available, they are going to assimilate this data. Radiance data from AMSU A, MHS, CRIS is the hyperspectral satellite, TMS. Radiance from geostationary and low orbit satellite, that is the GOES, Meteosat, Safir sounder from Megatropics, sounder and imager from 3D and 3DR. Precipitation rate also can be assimilated into the model. GPSRO bending angle also can be assimilated into model. Brightness temperature from ARC, META A, AS from ECFA. Data also can be assimilated into the model. So after assimilation, it helps to improve the forecast of the numerical weather prediction model. So you can this picture shows the operational forecast skill of the IMD. So you can see from 2003 to 2022, every 12-hour forecast skill. We can see that this blue and red linear line shows the forecast skill of 12-hour forecast and 24-hour. It has increased over the year. So this is due to the improvement in the data assimilation technique, improvement in the in situ observation, improvement in the satellite utilization of more number of satellite observation into the numerical weather prediction model. And similarly, that intensity also got improved over the year a lot. So they are able to accurately predict the tropical cyclone intensity also. So this is the last slide of this lecture. So whatever we have discussed about the tropical cyclone result, like size and center estimation using the satellite observation, you can find out there is a website that is called the Scorpio. That is the satellite-based cyclone observation for real-time prediction over Indian Ocean. So all the forecast archive is also available. So in the real time in the tropical cyclone form, you can find out the forecast over this website. Thank you for listening.